Hi, I'm Neil deGrasse Tyson, your host of Nova Science Now, where this season we're asking 6 big questions. On this episode, can we live forever? Some folks seem to be built to last. This guy's 91.
I'm 96.
97.
98.
These people live long and healthy lives. So what's their secret? And where can I get some? The answer may lie in these guys.
They're like 90-year-old people who look 45.
And what if you could replace your broken down human organs as easily as you replace the muffler on your car? Researchers insist that day is coming, and sooner than you think.
I absolutely see a day where there will be jars of kidneys and jars of livers and jars of lungs, whatever it is you need.
Also,
can I live forever?
just in case our human bodies can't live forever, this computer scientist is trying to design virtual replicas, avatars, that will.
An avatar is an instance of yourself that's digital, that will never die.
Inspired by Star Trek and Superman.
You do not remember me. I'm your father.
He thinks he can build digital copies of real people that will carry our thoughts, memories, and wisdom into the future.
You mean me?
All that and more on this episode of Nova Science Now.
Funding for Nova Science Now is provided by...
You know, we take it for granted that nothing lasts forever. And that's true of life itself. Every living thing will eventually break down and die. But does it have to be that way? Can we live forever? We begin our show with a man who seems to have done the impossible. He's completely stopped the natural decay and death that all of us expect. Not for himself, but for his car.
My name is Irvin Gordon. My car now has 2,741,000 miles on it.
You heard him. More than 2.7 million miles. The Guinness Book of Records says it's the highest mileage automobile in the world.
Every time the car goes out, I break my own record and make it harder for anybody else to catch up.
And they'd have more than 4 decades of catching up to do. He drove his new Volvo off the lot 44 years ago. And he and his car have been going strong ever since.
You don't have to be the fastest to drive 1 million miles. You got to just hang in there the longest.
So this is your baby, huh?
This is my baby. Don't touch that car. Watch your knees.
It's hard to understand how a car can last so long, look so good, and ride so well after all those miles. Irv's car has the same mileage as all of the Apollo moon landings combined. How many places on Earth and things to do take you 3 million miles to get there?
Commuting 125 miles a day to and from work.
125 miles round trip?
35 years.
Are you retired now?
I'm retired.
So what-
I
retired
retired
from what?
12 years ago. I was a science teacher.
Excellent. Most of the nearly 3 million miles have come from 44 years of crisscrossing the country. The odometer turns over every 100,000 miles. Do the math. It's turned over.
27 times. It's on its 28th.
So what does Irv do to get his car to live forever? Well, number 1, regular maintenance.
I just do the things that it says to do when it says to do them.
Things like regular tune-ups and oil changes. Irv figures he's gone through 110 tires, 440 spark plugs, 788 oil filters, and 3,143 quarts of oil. Sound like there could be some lucrative endorsement deals?
So they put you on the payroll, is it?
Yeah. Yeah. I'm still waiting for my first box of oil filters. Yeah.
Tip number 2, if something's broke, fix it. Replace the worn-out parts. Old cars drop oil. How much do you just drip out of this car?
You can go underneath my car with a rag, you won't find any oil.
Really?
Absolutely.
I don't see anything dripping.
Bone dry.
That's because, over the years, Irv has placed his car into the hands of an elite few.
This is my A-team here.
Richie Vermont serviced the car from when it was brand new until he retired 7 years ago. He's replaced 3 clutches and countless brakes and mufflers.
That sound like it popped.
Irv's maintenance bills helped pay for the education of Richie's kids.
I'll tell you, I send my kid to college.
The engine has been rebuilt twice. First by Richie after 680,000 miles, and in 2009 by this man, Dwayne Matika.
All right, what do we got here?
He said it was in pretty good condition.
Oil pump.
There was nothing wrong with the oil pump, but I figured after 2 million miles, it's a good idea to put a new one in.
Another rule of thumb.
Every 2 million.
Obviously, you replaced pieces of this engine. All right, does that allow it to count as the original car, even though you're replacing the parts that wear out?
Yeah.
Irv says it's not any different from a living organism.
Like your body replaces parts. How many times have all those different cells replaced themselves completely from beginning to end? Does that make you not you? It's the same argument.
And of course, Irv would know.
Well, this is coming from a science teacher.
And so Irv will keep on going.
Who would expect how a car would change your life?
When you look at pictures taken over the years, you see a man getting older, as his car remains as new as the day he drove it off the lot, more than 4 decades ago.
It doesn't show any signs of giving up. And hopefully this second rebuild will outlast my ability to keep driving.
And that leaves me with one last question.
Can I drive your car?
Absolutely not. Nobody drives my car but me.
Nobody.
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 If something in your car breaks or stops working, like your radiator, you can always just take it out and replace it. But what about us? If my body parts break down, like my heart, I might be able to get a transplant. But right now, even if I could find a replacement part, 1, it's going to be used, and 2, my body might just reject it. The dream would be to replace my heart or whatever's broken with a brand new version in perfect working condition, but exactly like my original. People have been talking about this for years, but now, thanks to some brand new discoveries, the dream of custom-made, personalized body parts may soon become a reality. In the 2005 sci-fi thriller The Island, people have found a way to live forever. They grow clones and harvest their organs. But real science may be on the verge of a less diabolical solution. This, for example, is no special effect. It's a lab-grown lung, no clone attached.
I absolutely see a day where you'll walk into a manufacturing facility somewhere and there will be jars of kidneys and jars of livers and jars of lungs, whatever it is you need.
Just as in The Island, your body would accept the new organ because it would be yours, grown from your cells.
And there would be no more waiting lists for organs. There would be no more rejection. We would enter a new era where we could build you an identical, ideal replacement.
But how do you make an organ without a body to build it in? We've been growing cells in the lab for decades, but they just sit around in flat layers or clumps. So how would you coax them to form a 3-dimensional organ like a heart, with chambers, valves, and blood vessels? Maybe it's the same way you go from this to this. See, an organ is not unlike a building. It's a collection of parts that has to come together and work together. Think of a cinder block as a cell. The problem is, a block or a cell alone is not enough. To construct a building, you need to begin with an internal framework or scaffold to define the parts and hold them together. 30 years ago, transplant surgeon Jay Vacanti and chemical engineer Robert Langer realized that to build an organ, cells also need a framework, a scaffold to guide their growth. The challenge was to engineer scaffold materials living tissue could grow on.
So this is a material that we call biorubber.
Biorubber, and you use the prefix bio because whatever is the material it will take to flesh or living cells.
That's right.
So why does the cell even care?
Because a lot of things could be toxic to a cell, or the cell wouldn't like their surface and wouldn't be able to grow on it.
Picky cells.
Cells are picky, and some are more picky than others.
But sculpting a scaffold out of the right material is only a start. To turn one into a living body part, an ear, for example, it must then be seeded with cells. A few weeks in an incubator allows those cells to multiply, covering the scaffold. Then comes a rather strange test. This is really creepy. I mean, mice are creepy enough, and this one has no hair and a human ear growing on its back.
Yes.
He doesn't seem to mind that he has an ear growing on his back.
No, he knows he's here for a bigger purpose. But this is a very, very important step in the science, because on the back of this animal, we're actually incubating and growing perfect cartilage in the shape of a human ear. And it's completely connected to the blood vessels, so that it's just like a native ear in a normal circumstance.
In the head of a person.
That's correct.
So when this finally gets implanted in a human, you don't expect rejection, as is so common with new body parts.
Exactly, because we're going to start with the patient's own cells. It'll make his own tissue, and therefore the body will accept it.
Within a year, Vacanti and Langer expect to be implanting their ears directly on the heads of soldiers wounded in Iraq and Afghanistan. But these will not be the first recipients of lab-grown body parts. Already, patients of other doctors have received blood vessels, skin, muscles, even bladders built the same way.
I think with enough research, most parts of the body will be replaceable. And I haven't come across very many body parts where somebody somewhere isn't working on trying to replace them.
Which is certainly encouraging news for people who need more complex body parts, like 20-year-old Stacy.
I was in the hospital, and that's when they came in and told me that I may need a new liver.
But will she get one?
Tell me if anything.
Every day, nearly 20 Americans die waiting for donor organs.
So this problem is an extraordinary problem. There are too few organs for the well over 100,000 Americans waiting.
But if we're ever to make the complex organs most needed to save lives, like livers and hearts, the scaffold builders will have to overcome an obstacle, namely plumbing. In a building, it's pretty straightforward. Pipes carry fluid where it's needed, just like blood vessels in the body, except that in a major organ, like the heart,
You need a blood vessel per cell because the heart works all day, every day. And I don't know if you've ever seen blood vessels, really, but they look like a tree. And the challenge is not to build that big limb, but to build those little tiny branches that come off.
But building these intricate branches might be unnecessary if we take advantage of a remarkable fact. Organs are not just made of cells.
So if you wash the cells away, what's left? Well, what's left are these proteins on which the cells sit, and they form the framework of the organ, the scaffold.
These natural scaffolds hold an organ's shape down to the smallest detail, including every blood vessel. So could they be used to build a complex organ like a heart? 6 years ago, no one could say, because no one had ever stripped a heart of its cells, leaving the scaffold intact. But Taylor's colleague, Harold Ott, thought he could find a way. He would use the blood vessels in a rat's heart to deliver a chemical that would dissolve its cells and nothing else. But which chemical?
So the process of finding the right chemical was literally a try and error process, starting from A to Z on the chemical shelf.
First, Ott tried enzymes, but they dissolved both the cells and the scaffold. Other chemicals caused the hearts to swell up. Finally, he tried a soap commonly found in shampoos.
We saw the heart become translucent. And it was obvious to us all that something had happened that hadn't happened in the months before.
What we had is this thing that looked like a heart, but it looked like a ghost heart, if you will.
Injections of dye showed the scaffold to be undamaged down to the smallest blood vessels. And we now know that this technique works with many organs, including human-sized ones.
This is essentially the scaffold of a heart. Who knew a heart had a full skeleton? But it essentially has no cells, dead or alive. It's beautiful. You can see the blood vessels here, the chambers of the heart. You can see the valves.
But could a bare scaffold once again become the framework of a living heart? Taylor soon discovered it was more than a matter of injecting cells.
Just putting cells on a scaffold isn't enough. It's putting cells on a scaffold and giving them an electrical signal and giving them a mechanical blood pressure and then giving them oxygen. It's not just a heart in a jar, it's a heart in an artificial body. So it's simple in many ways and it's unbelievably complicated.
After 8 days, the first lab-grown heart beat on its own.
It really makes you go, what is life? The first time you see something beat that was dead, it's one of those yes moments in life.
Since then, Ott has joined Massachusetts General Hospital and used the same method to build a pair of lungs. After coming back to life, one lung was successfully implanted in a rat.
So if you can make a working, living lung, then it seems to me you can
build literally any organ.
Any organ.
This novel approach has already made a difference in the real world. In Barcelona, Spain, this woman, Claudia Castillo, might be dead without it. 2 years ago, tuberculosis devastated her windpipe, making it difficult for her to breathe. But surgeon Paolo Macchiarini saw a solution. Give Claudia a new windpipe, which her body would never reject, because it would be made of her own cells, grown on a natural scaffold. And so, in June of 2008, Macchiarini and an international team of specialists removed a windpipe from a human cadaver, washed it clean, and reseeded it with living cells from Claudia's body. 4 days later, the new windpipe was transplanted into Claudia.
If you transplant an organ without tissue engineering, you need immunosuppression, you need close watching, and this was absolutely not the case for Claudia. She never had any sign of rejection. Indeed, 4 days after surgery, she was home.
More than a year later, Claudia is living a normal life, free of the fear that she will reject her new body part.
I feel like the transplant is not from the body of another person. It's mine.
That sense of ownership might soon be crucial to organ recipients, because their scaffolds might not come from a person at all.
This is a pig kidney sliced in half, and it's the same size, same complexity as a human kidney. We could cover this with human cells and, in theory, build you a kidney.
Human organs built on natural or artificial scaffolds? Made from a patient's own cells to avoid rejection? Available in unlimited supply? Most researchers believe it will be a reality within decades. And Taylor is even more optimistic.
Kidney, liver, lung. We're not decades away from building something complicated. We're more like years away.
Just like some well-made cars, some people last longer than others. They don't fall apart. They don't even need replacement parts. What's up with that?
You know, if medical researchers figure it out, then maybe everyone could last longer.
Correspondent Zaya Tom tracked down some lucky folks who don't age like most of us, and the doctors who were trying to figure out the secret to their fountain of youth.
So how'd I do?
Some people are like forces of nature. Aging gracefully is simple for them.
My name is Chuck Yogi. I'm 91 years old, ever since the last couple of days. So I'm fully 91.
Somehow, James Harai got to 91 too.
I've been blessed with good health, I guess, you know.
Kind of makes you wonder how they do it.
Do you have a secret to looking so young at 90?
Just don't worry about unnecessary things, you know? I'm happy-go-lucky.
But while these guys are living proof that longevity comes naturally for some, other people are pulling out all the stops to try and live as long as they possibly can. Computer scientist and inventor Ray Kurzweil takes 150 pills every single day.
That might sound like a lot, but it's not enough to just be natural. I take 400 milligrams a day of resveratrol, a lot of vitamin D.
So what's he doing with all those pills?
In my view, death is a great robber of all the things that give meaning to life. It destroys knowledge and wisdom and relationships. And there's actually a lot that you can do to slow down these aging and disease processes.
But is Ray wasting his time looking for a fountain of youth that's just a myth?
The goal right now is to live long enough to get to a future point where we will have technologies that will extend our longevity even further.
In fact, scientists have been tinkering in the lab trying to extend life for a long time, and they've come up with a couple of things that do work in animals. Calorie restriction, for instance. Basically, putting an animal on a diet seems to kick in a survival response and helps it live longer. And they found a substance in red wine that has a similar effect. But what if somebody could figure out how these guys did it so effortlessly?
The fish not cooperating today. I think the camera's shy of me.
Cynthia Kenyon thinks she may have found one of the keys to a long life in a tiny, nearly microscopic worm called C. elegans.
So how can we learn anything about human aging from these tiny little worms?
I know they look really different from us, but the basic processes of life are very similar at the molecular level. The good thing about these little guys is that they get old and die in just a little over 2 weeks. Okay, watch this. I'm going to show you something really cool now. So this is the normal worm when it's young.
So it's a nice sprightly worm, what I'd expect a worm to look like, quite feisty.
Now I'm going to show you the same kind of worms, but just 2 weeks later when they're old.
Wow.
So here, this is a normal worm when it's old, and you can see they're about to die.
Oh, wow. So these are really slow moving here. I didn't think you could see aging in a worm so dramatically.
Okay, so now what I'm going to show you are worms that are the same age, but you'll see that they look much younger.
So these worms are the exact same age as the ones that we saw that were almost dead?
Yeah, they look much younger, even though they're the same age.
And they're wriggling about just like the other ones, huh?
So they're like 90-year-old people who look 45.
That's incredible. So what's different about these?
We've changed one gene. That's all.
Kenyon changed one gene in the worm. Genes are made of DNA, long strings of 4 chemicals best known by their initials, A, G, C, and T. Together, they form the basis of all life on Earth. Kenyon found that there was a gene that scientists call FOXO, which had a central role in keeping her worms freakishly youthful.
What FOXO does is it helps the animal to protect and repair its tissues. The reason that it can do it is this one gene controls a lot of other genes.
FOXO is a master control gene, meaning it regulates hundreds of other genes that have a profound effect on the worm's health.
So you can think of it as a superintendent of a building. So if you have a building, nice big building, obviously it has to be maintained. What FOXO does, or the building superintendent does, is to keep the building in good working order.
The superintendent makes sure that the electricity works and that the roof doesn't leak.
It makes sure that the walls are painted by hiring painters. It makes sure that the floors are swept.
But the superintendent doesn't actually do all these important jobs.
The building superintendent would hire workers to do these different things. What FOXO does in the cell is it switches on other genes.
Those worker genes do jobs like enhancing the immune system and protecting the cells from bacterial infection.
Some of these genes that protect the cell make proteins that will kill invading microorganisms. Others are switched on that are antioxidant genes.
Kind of like a rust inhibitor for a cell. Now, most living things need oxygen, but oxygen can actually be damaging to cells that aren't prepared to deal with it. And yes, there's a worker gene for that too.
I'd say altogether there are probably about 100 worker genes that have very important roles. And together, what you get is a cell or tissue or an animal that stays in really good working condition for a lot longer.
All those processes are actually directed by the FOXO superintendent gene. Kenyon tweaked one gene in the worms and made FOXO more active. With a more active superintendent, the cells became more resilient than normal, and Kenyon's worms lived twice as long. If there's one gene that dramatically increases lifespan in worms, could the same be true in humans?
I went to Alaska 10 times.
Yeah? They have big fish in Alaska, right?
Mr. Harai and the others are part of a groundbreaking 45-year study in Hawaii that's trying to find out.
The Honolulu Heart Program population is a group of Japanese American men.
Beautiful sunset.
That we have followed since the 1960s.
When you hear people my age, they say, it's so hard to even get out of bed. So I said, so why don't you jump up? But they said, no.
What's he have that other people don't?
35 times.
What's important for aging is it's a process. So we've studied the process in these men for decades.
Wilcox and geneticist Timothy Donlan wanted to see if they could find out anything about the genetics of human aging from this unique scientific resource.
This is one of the freezers that houses the over 8,000 samples from this project that's been conducted over the last 45 years.
Wow, so this is like data frozen in time.
That's right, safely tucked away here.
Using these samples, they tested 5 genes that had already been shown to help animals live longer to see if any of them would extend human life as well.
And based on that list, we found one gene that was heads and shoulders above everything else, and that was the FOXO gene.
The FOXO gene, that's right. The same superintendent gene that helped double the life of Cynthia Kenyon's tiny worms. Though everybody has the FOXO gene, these Hawaiian men seem to be living longer, healthier lives because they have a protective version of FOXO.
We found that if you have this FOXO gene, you have a 2-fold chance of living to 100. And if you have 2 copies of this, you have a 3-fold chance of living to 100.
A gene typically consists of 2 copies. You get 1 copy from your mother and 1 copy from your father.
So with FOXO, the area that we looked at, you could have a C or a G from your mom and your dad. The vast majority of us have 2 Cs. About 25% of us have 1 G and 1 C. And about 10% have 2 Gs. If you have 2 Gs, you hit the jackpot. That's triple the odds of living to be 100. You can go to Vegas with those odds.
I'm not very good at this, but I read palms a little bit. And believe it or not, you actually have an incredibly long lifeline.
No kidding.
Yeah, you do.
And not only triple your odds of living that long, but being healthy. So it was a gene that appeared to be associated with extended health span, not just lifespan.
It tells us that FOXO in humans affects aging. You could have imagined that we have the gene, but it doesn't do the same thing. But this says it does.
News of the Hawaii study sped around the world, and scientists confirmed the results in population after population in Germany, Italy, New England, California, and in China. Nir Barzilai of the Albert Einstein College of Medicine in New York
I am now 98 years old.
also found a similar pattern in the FOXO genes of Ashkenazi Jewish centenarians.
I'm 96.
97.
98.
This data on the FOXO pathway that came from Hawaii and then confirmed by us was confirmed by other groups, and in fact it's the most consistent, validated study in this field, suggesting that this is real and important for human aging and longevity.
You don't feel old. You feel young.
And it's also consistent with what we have learned, that there's this whole concept of a superintendent that is regulating whatever is going in the house.
Oh, you gotta go. And in the future, that knowledge could be used to develop new drugs to combat age-related diseases.
Fish on.
And perhaps someday to help us live longer.
Good job, Mr. Harai.
The vast majority of us get an average set of genes. So it's what you do that becomes most important. Eating a good diet, regular physical activity, engaged in life.
As you age, I think every little thing pleases you more than in the past.
And now I gotta aim for the century mark, yeah.
So how do you think you're going to celebrate your 100th birthday?
100 candles would be a fire hazard, huh?
Yeah, it would be a fire hazard.
At least for now. It's much easier to extend the life of a car than of a person like you or me. The car's not flesh and blood and complex organs. But what if you could create a version of yourself that was indestructible? In this episode's profile, we'll meet a computer scientist who wants to build virtual versions of ourselves. Avatars that look, act, and talk like real people, and will hang around long after the flesh and blood versions of us are dead and gone. In 1987, when Jason Lee tuned into Star Trek: The Next Generation, he saw the holodeck for the very first time.
I was curious to see how 3 of history's greatest minds would interact in this setting.
A place where people from the distant past can live on as computer-generated holograms.
End program.
And that's when a sci-fi TV show gave this computer scientist his big idea. A way to allow all of us to, in a sense, live forever.
If you were to think about that when Star Trek first came out, you would think, oh, this would be impossible to do. But now it's possible.
At the University of Illinois, Chicago, Jason has been obsessed with turning his fantasy into reality through Project Lifelike, a plan to make immortality available to anyone by creating a virtual copy of you as an avatar. A concept that intrigued Jason long before James Cameron parlayed it into a billion-dollar blockbuster.
An avatar is an instance of yourself that's digital, that will never die.
Jason knows he can't really make you live forever, but he can use computers to preserve your thoughts, memories, even the way you look, for eternity.
Can I live forever?
In the future, your children's children will be able to meet with you. Students will be able to talk to scientists long gone, like Stephen Hawking or Neil deGrasse Tyson even.
Who, me? Well, I'd be honored. Jason's vision of a world where we can build relationships with dead people, from the famous to family members, was deepened by another movie.
In the film Superman, Jor-El, who's Superman's dad, is long gone and dead.
You do not remember me. I'm your father.
But instead is able to counsel him as if he were still alive.
Jason's journey began in 1960s Hong Kong, where he was a shy, awkward boy with no real friends.
I was really, I guess, a geek would be a good term for it, but I was also artistically inclined. I was drawing anything I saw in science fiction.
It's a missile, and it's headed straight for us.
Star Wars blew my mind. All these wonderful and cool technologies that we as mere mortals living today didn't have access to.
And before long, Jason was drawing his own inventions.
I remember we had these 3-ring binders, and the paper would always rip. and it just drove me nuts. And so I was imagining some futuristic computer. It wasn't a computer back then. I didn't know what a computer was. A futuristic magical pad where I would write on. And of course, nowadays we call it a tablet computer.
And we call it the iPad.
If only I had patented back then.
Then, Jason saved up to buy his own computer. And he instantly became obsessed, spending 9 hours a day at the keyboard.
Even when I went to sleep, I was writing code while I was asleep, and I would find an error, and I would wake up, and I would find, yep, certainly there was an error in the code.
When Jason left Hong Kong to go to college, he had promised his parents he would study the well-established field of chemical engineering. But he had a secret plan.
The first day I landed in the US, I head straight for the computer science department and said, how do I switch majors? And then I wrote a letter back to my dad and said, I switched to computer science. He was actually supportive.
After college, Jason was eager to make his mark designing computer graphics. And he learned about EVL, the Electronic Visualization Lab in Chicago.
It was people who had long hair, all sorts of strange and crazy people.
These self-proclaimed techno-hippies were finding new ways to merge computers and art.
And I thought, wow, finally, a program that thinks and does things the way I've always wanted to do. I said, well, I'm going to just let my hair grow out. So I fit in and became one of the techno-hippies. So I think it's a great time to be a geek.
At EVL, Jason blends games and movies into every aspect of his life. From his work, to his play, to his car, and even his kendo, which is as close as he's going to get to a lightsaber battle in Chicago.
He very much is bringing Jedi Knightism into reality. No respectable Jedi Knight would use any other Jedi's sword.
After 15 years, Jason became lab director. And he could now take aim at his most ambitious sci-fi fantasy, how to create a realistic avatar. Still an artist at his core, Jason used art as inspiration and his drawing skills to develop ideas. In 2007, Jason joined the growing field of avatar researchers as he began work on his plan to live forever. As usual, Jason started with a drawing.
I always start with a picture in my mind. The picture goes onto paper. The picture goes into the computer. I spin the thing around to see if it makes sense.
Next, Jason had to make an avatar look like a living, breathing person. For a guinea pig, he used himself.
First of all, we take photographs of their face from multiple angles so that we can use software to reconstruct the face in 3 dimensions as realistically as we can.
Then Jason teaches his double to move, just like he does.
And so for that, we put them in a motion capture suit.
Jason even records and modifies his avatar's emotional expressions.
Like whether they're happy, sad, angry.
Let's look at a little bit of anger. There you go.
As Jason fine-tuned the graphics, he needed to teach his avatar to think and talk. So he turned to artificial intelligence experts.
Our collaboration involves researchers in Florida.
To overcome the 1,000-mile gap between collaborators, Jason's team invented their own 20-foot video wall. So the researchers in Chicago and Florida could work on the avatar's intelligence as if they were in the same room.
The avatar doesn't use its hands now to talk, and I think at some point we're going to need to show some hand-waving motion.
Jason records the ideas and thoughts he wants his avatar to express.
Designing computer algorithms is like writing poetry or painting a picture.
So that someone can sit down and ask his avatar dozens of questions.
Why is Star Trek important to you?
Star Trek portrayed so many compelling ideas about our future.
And this idea of preserving our life experiences for future generations has been catching on.
When I watched Avatar, the most interesting notion about it was when these people passed on, their knowledge is absorbed into this tree of past knowledge. And I thought, aha, that's what we're trying to do. Ultimately, what you have is a collective knowledge of people.
Jason dreams of a future where anyone can program all of their thoughts, feelings, memories, hopes, and fears into a virtual replica of themselves, so people can actually speak directly to those long gone.
What we'd like to do in the future is to try and break the avatar out of the box, make it a person in the real world, conversational avatars that are as intelligent as humans.
You mean me? You mean I'm not really alive?
Most things that break in a car can be fixed, but every now and then, some things can go catastrophically wrong.
And the results could be fatal.
In those situations, if we could freeze time, we could fix the problem before the worst happens. Well, some doctors think they can do just that with people who are in the middle of life-threatening crises, like a heart attack or stroke. Correspondent Peter Standring found out how freezing, or at least slowing down time, is already saving lives.
All set. Drive safely. Thank you.
Every once in a while, there are news reports of miraculous survivals that seem almost too incredible to be true. People who drown in icy water, or are buried in snow. Their hearts stop beating, and they're getting no air. They seem to be dead, yet mysteriously, they come back to life.
I got a pulse.
Somehow, their bodies seem to go into a state of suspended animation, so they can survive without oxygen for an hour or more instead of mere minutes. But how? Researchers have been looking for clues in some surprising places. Starting with this guy, the 13-lined ground squirrel. He might not look like he has much in common with near-death survivors, but in fact, he's an expert at surviving an experience that seems like it should kill him: hibernation. Today, I've come to Minnesota in search of these hibernating squirrels. And it's freezing.
So the squirrels are actually underneath all of this snow and under the ground right here?
All around here. The animals are probably about 4 feet below the surface of the snow.
Man, how do they survive that?
That's a great question, and it's something we're trying to figure out in the laboratory.
Matt Andrews is trying to unlock the secrets of hibernation.
Here in Minnesota,
could the hibernating squirrels have something in common with people who mysteriously come back from the dead?
So what is this place? What is this room, Matt?
this is the environmental chamber where we keep our animals in a state of hibernation.
Why are we whispering?
We want to duplicate the conditions that the animal experiences underground during the winter, and so we're duplicating that here in the laboratory setting.
The squirrel's dark laboratory home is kept at 40 degrees, about the same as it would be underground.
So underneath all of this sawdust, we have our 13-line ground squirrel.
This is exactly what they would look like when they were in their burrow. And there is a hibernating 13-line ground squirrel.
Comfy, cozy, rolled up in a ball.
And this is the way that this animal spends the winter. It can survive in this state for months. Would you like to hold one?
Absolutely. Wow. Look at that, my very own little bundle of fur. I think it's the first time I've handled a hibernating animal.
When these squirrels go into hibernation, it's an amazing process. their heart rates drop from 300 beats per minute to 3 or 4. Their body temperature drops from about 98 degrees to about 40. They only take a few breaths a minute and use barely 2% of the amount of oxygen they need when they're awake.
Now, you might think that all of those drastic changes would be enough to kill off these little guys. But despite it all, they emerge from their long winter slumbers completely fine. There's no damage to any of their organs, there's no damage to their brains. It's really incredible.
Okay, it's time to put them back to bed now.
Okay, make sure you tuck them in good.
Hibernation is deeply mysterious.
So, Ann, what do you have going on here?
In his lab, Matt Andrews studies its impact on genes. He's discovered several genes that get turned on in some cells only during hibernation. He hasn't completely solved the mystery, but one thing is clear. Somehow, those genes seem to reduce the hibernating squirrel's need for oxygen. Andrew's ultimate goal is to figure out how we could do the same for people.
If you can understand the molecules that are expressed when an animal hibernates, you can possibly develop a therapy that can mimic the hibernation experience so that a person can survive a traumatic injury, a heart attack, a stroke, those sorts of things.
Pulse. Okay, begin CPR.
Heart attack victims usually die from a lack of oxygen.
Keep track of that and let me know.
But if we could reduce the body's need for oxygen, even temporarily, who knows how many lives could be saved? While the squirrels do it with their genes, those drowning and avalanche victims who come back from the dead somehow appear to survive without oxygen because of the cold.
130 was the lowest blood pressure.
Now, at a handful of hospitals around the country, emergency room doctors are attempting to replicate those miraculous recoveries. Todd Vandebush is living proof it can work. Todd was just 39 years old when one day he collapsed in the shower with a sudden cardiac arrest.
All of a sudden, Todd fell over, and then he stopped breathing.
When the paramedics arrived, Todd was technically dead. Luckily, he was brought to this ER in Virginia, where doctors are trying out a new treatment.
It sounds like EMS got a pulse back in about 20 minutes. Stand by.
While one team worked frantically on Todd's heart, another flooded his bloodstream with a solution of icy fluids and drugs.
By cooling as quickly as possible, we're trying to lower the body's metabolism. We're trying to lower the rate at which the body consumes and burns up oxygen.
You're gonna have to wait till we get these tubes all set up. We're hurrying as fast as we can.
As the cold fluid flooded his veins, Todd's body temperature dropped from 98 degrees to about 92. His heart rate slowed, and all the cells in his body used a fraction of their normal oxygen. Much like the hibernating squirrels, Todd's body was carefully put into a state of suspended animation.
We're trying to stretch time to give the body a chance to recover from the cardiac arrest.
24 hours later, Todd was slowly warmed up and brought back to life. Now, 2 years later, he's in good health and enjoying life with a new baby.
We're seeing that some of the patients that years ago we thought could never survive are now waking up and going back to a fully functional existence.
This cooling therapy is still relatively new, but in the few places it's been tested, it's substantially increased survival rates for some kinds of heart attacks. And Todd has had one of the best recoveries so far.
I've gone through it, and look how well my outcome has been. It's truly a miracle.
And now for some final thoughts on living forever. The urge to not want to die is as natural as life itself. But you should always be careful what you wish for. One day, it might just come true. If starting now, everyone in the world lived forever, then Earth's current population of 7 billion, which would, at its current rate of growth, double in 60 years, would instead double in only 35. Take this forward 6 centuries or so, and you have so many people on Earth that everybody will have to stand up straight just to fit on all the world's land area. So that leaves interplanetary colonization as the only obvious next step to accommodate such vanities. But not all planets are Earth-like. Actually, none of the known planets, inside or outside our solar system, are Earth-like. Which means, if biomechanical genetic engineering is what grants you immortality, then why not alter or enhance our organs in ways that allow us to thrive under the exotic conditions of alien planets? And that could be only decades away. There's just one catch. You need a space program capable of leaving Earth entirely, rather than just driving around the block in Earth orbit. Until then, our bodies may out-advance our access to space, making Earth a very crowded place to come. And that is the Cosmic Perspective. And now we'd like to hear your perspective on this episode of Nova Science Now. Log on to our website and tell us what you think. You can watch any of these stories again, download additional audio and video, explore interactives, hear from experts, and watch revealing profiles of our web-only series, The Secret Life of Scientists and Engineers. Find it all at pbs.org. That's our show. We'll see you next time. See a hidden side of science on Nova's web-exclusive series, The Secret Life of Scientists and Engineers. Think you know scientists? Think again. Nova's The Secret Life of Scientists and Engineers.
This Nova Science Now program is available on DVD at shoppbs.org or call 1-800-PLAY-PBS.